Okay, so I'm going to speak about the new protocol, HTTP3, and I'm going to speak also a little about the HTTP2, which is not so new. And the talk mentioned SSL and TLS, but I will only go briefly on the topic. I have a bunch of a demo and a bunch of a small hardware, which I don't know, at some point it should start. And you know, I like demos, but usually my demos are not working for different reasons. So what I will cover the new protocol. Basically, I'm not going to go into detail how it works, but you can ask questions. I will do my best to answer. I've read part of the spec. I understand more or less how it is, so I can probably give some of the answer. I can speak about the. I'm going to speak about the H2. I'm going to speak about the H2 and the ALPN. I'm going to give a brief status of where we're at on our server, on HTTPD, on Tomcat, and TrafficServer, and then I have room for demo, for my demo, and some questions. Don't hesitate. Stop me if you have a. If you have a question, because if we put all at the end, I may not have time to answer the questions. So I was already presenting. I guess you all know me. I'm Jean-Frederic. I'm living in Switzerland, and I'm a runner. I've been running this morning. I was a bit disappointed. I was alone running in the rain. But that's happened. I started in my hotel, it was not raining, and arrived at the place where the people were supposed to meet, it was raining. So I was running anyway. So let's jump directly in the slide, but I'm going to just basically tell what happened. Why are we doing so many new protocols? Well, we have discovered that HTTP 1.1 is not the best performance for the browser, for the rendering, because basically you have to multiplex, you have to establish several connections. Establishing a TCP/IP connection is taking a lot of time, and definitively if your browser needs something like 10 connections to get a page, it's going to take several milliseconds until something can be displayed. So there were different intents to improve these things, like telling the browser to open more sockets to the servers, also trying to keep them open and reuse them, but that's still not perfect. So we were coming with a new protocol, HTTP 2, which basically still use TCP/IP, and basically it opened one socket between the browser and the server, and in this socket we're going to multiplex the request we need to build the page. But this is still not perfect, because it's a connected connection. The TCP/IP basically. If one packet is lost in the middle, it's going to block everything until this packet is repeated. Definitely, if it works a lot better when you use H2, but still, if you lose one packet, you are in trouble, and you're in trouble in all your connections. So a new idea was developed. It's like, why not using UDP? And the advantage of UDP, as you not need to acknowledge the packet you're sending, you can prevent this blocking situation, because basically you can still be sending things for one part of the page while another one have been lost. That's the browser that way can still try to display something while he will at some point ask the repetition of the frame that he have not received. Basically, so the new H2 protocol, it's in progress. They have been drafted regularly. I did the presentation in Las Vegas. It was one version of the draft of the specs. Now there's a new one. They are somehow incompatible, or somehow the server and the browser does not want to support more than one. So basically, if you recompile something with the new your library somewhere and it uses the new H3 protocol, basically it's going to be not working. And I have not investigated why, but I think it makes sense when you are developing something, not having to support all those many protocols. In the case of H2, they were supporting several versions, but that was a lot more easy because it was adding stuff on it. Here it's a bit more difficult. So H2, it's using Quick. You need to use TLS 1.3, and it's using UDP. Basically, the idea is to be able to transport HTTP 1.1 like H2 is doing. To do the initial connection, in some cases, basically, you don't know that your server is going to be able to make H3. So basically, you can send a normal HTTP 1.1 request with a special. No, you may get to your page, and you're going to get in a response a special header, which is a response with an alternate service, and the alternate service is H3 in my example, and that's the port where H3 is running on that server. Then the browser will could go on either staying where he is or going to use H3 on that port. H3 have a bunch of problems because in a lot of places the people have been closing the UDP port because they were thinking like, well, that might be a security issue. It's quite easy to think that UDP is probably slower than TCP/IP in the kernels because basically it has not been so used. And we can assume that it's probably not so fast and not so well done. It's basically like it's all the problem of all software. The more it's used, the better it is. So we know that that part has not been used much, so it might be that there's some deficiency. Additionally, definitively, this protocol is going to require a bit more CPU, probably a bit more memory, because basically you're going to have to check each packet you're getting to make sure that you can reorder it the right way, and to see if there's not anything missing before starting to display the image, for example. The specifications are based on several RFC. Exactly, there's 6 RFCs for the moment. I don't think there's going to be a new one, but we never know. So, how you are able to do it, to start to play with H3? Because it's, as I was saying, it's still a draft. So I don't, apart Google, Facebook, and Cloudflare, I don't think anyone have really using it intensively for the moment. What do we have? What could we already test? So you can have curl since recently can do HTTP3 directly connected using UDP or using the alt service way by basically sending a GET request and reading the response and reconnecting using UDP. You need some extra libraries in most of the case. In case to use curl, you can do it using Quiche or ng TCP2. We have been looking in our server. In Tomcat, we have a different problem because that requires UDP. The UDP API is quite incomplete compared to the TCP one. So it's probably quite difficult to implement these things. We don't know yet how we're going to do that. In Apache HTTPD, it needs some time. It will probably use an external library. We don't know yet when we're going to start to implement it. It's some work, and apparently the the adoption of this new protocol is not that fast. TrafficServer, they have been very active in this area, so they are planning to have at least support the current draft at some point at the end of this year. So basically, if I want to, I will make a very short demo later on using the TrafficServer and the curl. A curl that I have compiled with Cache because you need different things. First you need a modified version of OpenSSL because the H3 protocol allows different fast connection, zero round trip things, which are not by default in OpenSSL. So you need to have a small patch in OpenSSL. The code is available. You just need to compile your own version, but it's good to experiment, but it's still quite far from production. So I will jump a bit over these things and come back while I will be doing the demo. Because I already did that presentation, and I know I'm going to run out of time otherwise. So I'm going to re-explain a bit, like I'm insisting on the message somehow. So this is the slide I was using when I was presenting the H2 protocol, and this is valid also for H3. Basically, HTTP 1.1 is quite old. It's like the Apache Software Foundation. It had been out here for a long time. And it was prepared for what we were using at that time. I had a server at that time running on a huge desktop, and I was just serving a small image and 1 or 2 HTML pages. Now, if you have your own server at home, you have a huge page. You're going to have a bunch of image, JavaScript, and a lot of stuff. So definitively, the design of the protocol start to be completely inadapted, because you imagine to serve all those pieces according to the protocol, you have to open a connection, and to render these things, it's very, very slow, because you get the HTML page that you start parsing, and then you're going to open new connection, and then you're going to get all those things one after the other. So we had to look for something new. So what could we do to make something new? First, we make it a bit binary. You know, all the headers, they're going to be the same. So basically, you have to, if you have a binary protocol, you can compress things. You can have all the headers compressed or encoded. You can have frames, and you can multiplex the things. Basically, the browser is going, instead opening several sockets, it's going to open one socket, and it's going to multiplex the data in this socket. H2 is based on Speedy. It requires you to use TLS. I mean, the browser can't do anything else than HTTPS, and they requires a strong cipher. You can do forward proxy, but of course you can make reverse proxy. And the reverse proxy is basically, we have a version of the protocol which is without encrypting. Definitively, that might not be the best idea, but basically that allowed you to basically do the TLS termination on HTTPD, and then having the clear text H2 run on a Tomcat, for example. Anyway, I will again say that now if you want to be really safe and secure, it's not a very good idea that somewhere, even in your supposedly safe intranet, to have something which is unencrypted. Because basically, at some point here, you are going to have something which is compressed, but it's unencrypted. So you can someone in the company, in the intranet, could sniff this data, which is probably not what you want when you are a bank. So more and more of our customers are usually requesting that everything stays encrypted all along the way for the data until they arrive in the application. Any questions so far? I'm going too fast. Okay. If you look to H2, basically it's based on two specifications, on two RFCs. One is the header compression, and definitely this is one of the parts that is changed in H3 because this supposed to come kind of some order of the data, which we can't warrant it in the H3 protocol. So those are not different in the case of when you're using H3. That's why we are more RFC. What does it use also? It uses the application layer protocol negotiation. So this is something which is going to be in the first TSL packet, which is exchanged. And basically, the client is going to tell, I'm able to do that. And the server is going to answer, well, let's do this one. I have. So multiplexed means that basically you can exchange in the same socket. So this big bluish stuff is supposed to be a socket. The things inside is supposed to be a stream. A stream corresponds to basically one request response process that you do in HTTP 1.1. So for example, you can have a header which is answered by a header. You can have a bunch of header and get some data. In the case of a gate, you can have a data and headers, and in the case you have something like a post. And the interesting thing is like basically your server is able now to push some data to the browser. That could be interesting. For example, if you have if you know your page is going to have a large JavaScript, it could be interesting to push this JavaScript while the customer is trying to make a choice, like choose one or two. You need some time, so it could be a good moment to send something to the browser so that he can put it in his cache. One of the issues is like actually I was trying something is to send images. Like basically you know that at some point you're going to have images and then you want to send them while the customer is making a choice. That is not working, but JavaScript is working. So that could be very interesting. Like you imagine you have a bunch of choice, you're going to use the same JavaScript or you need a JavaScript to validate different things, then you can send them while the customer is making a choice, which definitively will make your server with a lot better latency, because when the guy will click one, he will have what is in the choice one with already all the JavaScript he needs to make the validation in the next page. That's the idea of the server push. Of course, it depends on your application. You need to prepare the stuff a little. So the header compression, that's going to be to save something like 80% of what you need in the header. It's especially interesting when you have small pieces or a small. You have a request that have several small requests with a small answers, because basically you're going to get there. You can handle priorities on both sides. The browser can tell like I want to get this first, and the server can tell I want this first. The server push, as I was mentioning, definitively that will prevent something which is taking a lot of time, which is basically the browser saying like, oh, I need the JavaScript, and you need to open a request and get it. And of course, if you already have it, it's going to be a lot better. So all those new protocols are basically not to make the people that are doing Tomcat and HTTPD or TrafficServer their life more easy. It's just to get a faster and a better rendering on browsers. So this is for the final user, and then we are making servers. So basically, for us, it's tend to be more trouble than any other thing. So if we look to H2, it has been there since a long, long time. I don't think if anyone is still using a Firefox 34, but I guess that's already some very old one, like Chrome 30, Internet Explorer 11, Opera and Safari. That definitively it's supported. Some people have. So that's the data from a year and a half now. The TrafficServer people are tracing the different requests they're getting, and they were noting that 80% of the traffic, or around 80% of the traffic, was using H2. They have their server with H2 enabled, and then that way they say the estimation is like basically there's a very small, there start to be around 20% of the people that don't have a browser which is able to do H2. So we're going to go a bit deeper in the in some more details in order to try to show a little how those things are working. So this is a client Hello. This is my laptop. I need to drink something because I have to have another talk. If I get dry, I will not be able to do it. So basically, this is my Firefox that make a request, and this is a Wireshark capture of the connection. It's not a very recent one because it's using TLS 1.2. You can see that you have a client Hello, which is going to be answered by a server Hello, and this is the detail of the client Hello, and the browser, the Firefox, is telling all the H2 is able to do. Like this, these are the different variants of the protocol. This is the actual one. He is also telling that he is doing speedy, which I don't think anyone is using anymore, and he is also doing HTTP 1.1. He will always be doing HTTP 1.1. Usually, that's the kind of like if you are a browser, you have to support the old protocol for a long, long time. So the Tomcat is going to answer. It's really a Tomcat. It's not that I have written Tomcat because it's a Tomcat track. So this is the answer from Tomcat. The in the server Hello, the Tomcat is going to send the ALPN extension. You have the length, and then it's going to tell those things are are not cryptic at all and be redundant. You could have a 0 byte and then you would know the length, but that's it. So you have the length, and then it says that the next protocol you want to do is H2. So as the browser was saying, the browser was proposing H2, and Tomcat says, yes, I can do that. So those requirements, in fact, now they looked a bit quite old because basically, who is running OpenSSL 1.1 something? Okay, you're a bit alone, but yeah, I think that's a good idea. So who is running something older than 1.0.2? Okay, so if you would be running one of 0 something, you definitively have a big problem. You probably even no one can connect to your server, because at some point the browser have been more and more restrictive in order to protect customers. So at some point everyone will have to upgrade to a new version of the protocol, even if TLS. Probably TLS 1.2 is going to be here for a long time because it's kind of it used to move fast and it start to move a bit slower. And okay, if you are using Tomcat, this is in Tomcat since Tomcat 8.5, so it's going to be in 9. You need to use a Tomcat native. The version need to be new enough. Or in fact, don't use that version of Tomcat native. Use the latest release, because this one is an old one. Or Java, which is higher than Java 9. This is why Remy had problem with Graal. It's Java 8, and it does not have the ALPN, so you can't basically decide that you're going to do issue, because you can't analyze the message the browser is sending. So basically what you're going to do is, like, as you can't analyze the message, you can't decide, so you're going to do HTTP 1.1. So if you look in HTTPD, it has been there for a long time. As I was mentioning before, it's using an external library, libng HTTP2. This is a small C library, which is available on all distribution. If you look to TrafficServer, they have implemented the full H2 stack in TrafficServer, so they don't depend on anything else than OpenSSL. So basically, you get TrafficServer. If you compile TrafficServer, the only dependency you have is OpenSSL. Okay, so I will. When it's written 8.5, it's also 9. So it's in case of Tomcat, we have a full support. It's stable. If you want to use a server push, you need a recent version of the servlet. The thing is, like, basically it can't be full Java, as I was mentioning. In HTTPD, it has a full support for a long time. And in TrafficServer, they have nearly implemented everything. This is the version of last year. So I have some slide on Tomcat, and I have some slide on HTTPD, and I have some slide on TrafficServer. This is not. I should have updated these things, but basically, what is interesting to see is, like, in case you want to do the protocol, the only thing you have to add is one line in your configuration, which is this line or this line. So so if you look, where did I put the two examples? Oh yeah, this is using the ALPN protocol. So this one is also going to work with Java 8, and this one uses the NIO connector. Then it's going to require, if you want to do H2, it's going to require a version of Java which is higher than 9, and actually it's going to be 11, because I don't think you want to use something which is not long-term support. How I'm going with time? Okay. So, in case you want to use the APR, which is the first example I have, you have to configure. Either you have to have your Tomcat native library in the Java path. Either you need to export it via LD path. And this is an example of the first one that was working. There was the first one that was working. When you look, this is using LDD to see what it's linked with, and then I was engaging the people to check that when they build these things on their own to make sure that it's linked with the right one. You have to have a version of OpenSSL which is early enough, and API does not really brings any problem because we don't use very complex feature of API. And nowadays, in any distribution, you have all you need. As it's still Fedora 23, and I'm running Fedora 30, so it's a bit long. So those are all old tests. I didn't redo them, but well, I did ruthlessly check that it was still making sense. Like I take 2 points, and so basically here the idea is to say like, okay, this guy is telling us like we need to try the new protocol. Definitively, that's surely have a cost because we're going to multiplex, compress, so you're going to have to demultiplex and uncompress. And the idea was to look a little how much load we can get out of the stuff. And definitively here it's a load test, so it's or a kind of bench. So it's very you can make the bench tell what you want. So. But you can see part of what I was trying to explain here is like if you have big, if you are sending big binary file, the concurrency, the throughput you're going to get is going to be more or less the same because basically you have a very little overload because you just have a little part of the multiplexing, demultiplexing. If you are sending small packet. You need to consume a lot more resources, and so this is the CPU usage because one thing is the throughput you can get, and another thing is to get the CPU usage. So here, well, we see first we don't fill the CPU completely, which is in the case of a bench is maybe not what we wanted, but more or less that you can see you need an additional 10% of CPU resources if you use the new protocol. And that's not an application, that's just a load test. That's always the difficulty, but if on a load test you have something 10-20%, definitively if you want to move to the new protocol, you must make sure that you have enough CPU in order to see a gain. Because if you overload your server, using the new protocol is not going to help. So I will jump on the server, on the demo. The demo are taking a lot of time, so I'll do them if there's no question. By the way, any question? Anyone using TrafficServer? Okay, I'll just go very, very quickly on the thing. So TrafficServer is a reverse proxy. It had a lot of caching. It was used and it was donated by Yahoo, and it's widely used on people that have a need of a fast proxy. It had somehow it can serve static pages, but that's not the idea. That's basically the idea. It's a proxy, and it's able to cache requests. It's able to cache the response and the request in order to optimize the throughput. So what is interesting to see here, we tell it that it's going to use H2. We tell here in this example that he is able to use TLS 1.1 and TLS 1.2. We give him the key and certificate. We ask him to map anything to Tomcat, and they're a bit picky with the allow, which makes sense. They want to protect their server, so you need to tell that what you are allowing. So in this case, I was allowing my own address, which is probably not a good idea, and any IPv6, which is probably also not what you want. But that's just an example that you can see what you need. And then all these things, the things in HTTPD, you have one big file. In TrafficServer, you have a lot of small files. And I like HTTPD for one reason, it's like everything is in one file, and I dislike it for the same reason, because if you are doing some tries, you end up with a huge file and you don't know what to do with it. In TrafficServer, everything is in a small file, so when you start to use it, it's very, very annoying, because you never know where you have to put the stuff. You need to read the documentation again to make sure, like, okay, where does this go? And then you start the server and then you still can't connect to it. It says forbidden. And then you say, oh, yes, of course, I have to allow my own IP, because by default it's allowing nothing, which is a way to make the thing safe. Like, if no one can enter, you're sure it's good. So, so my experience is like, if you use it regularly, it's probably more easy to configure and tweak than the HTTPD. But if you are the first user and you want a reverse proxy, use HTTPD, because you're going to be bitten by these things, and it's not very nice, and it's a bit annoying. And it's very easy to make, especially on these things where you can control the entry address or the remote address, you really will really quickly screw it. But well, the doc is very good, so if you're motivated, definitively, and if you want really something which is fast, you can go for it. Because always remember, with HTTPD, you can do a lot more, which is probably what you're doing. But with TrafficServer, as you can do only what a reverse proxy is doing, you can optimize things a lot more easy, and you don't have some kind like, why do I need to use mode read right here to do these things, or things like that. So I will skip the demo. So let's look a bit what we configure in HTTPD. So in HTTPD, it's quite easy. We just have to load the module. Here we create a virtual host to use it. We tell it that we want to use the two protocol, and we ask it to honor the order of the protocol we have put there. So basically, the browser, if he's able to do H2, is going to do H2. We need to use SSL, so this is a very, very simple open SSL, mod SSL configuration. You say SSL engine on, you give it the SSL certificate. It's my own certificate, and I have my own PKI on my laptop, because I'm doing some crypto stuff. So usually I can, that way you can try things in a very easy way. Of course, if you want to use your own, you have to import this certificate in your browser so that you can recognize it. And you can't import that format in the browser directly. You have to convert it. But OpenSSL is doing this for you, and there's tons of documentation. So here I was doing the same test with HTTPD, because I also wanted to see what happened. Here you can see that basically it seems to be more performant. And if we look to the CPU, you can ignore the bump on the top. I've redone this point, and I forgot to change the slide. So the things are a bit more together. So basically, this is the CPU usage. I was not trying to fill completely the CPU. I guess at some point I'm limited with my network. That's a big problem when you bench things. It's like now CPU power is quite inexpensive. So at the point you fill the line, and then you have all kind of side effects, and you're not measuring the performance of your server. So, but you can see here, basically, it's very similar. I'm basically using HTTPD. Well, my customer are using HTTPD as a proxy. So this is an example of a HTTPD proxy configuration. we have to put the mod proxy h2, and here you have the configuration, and here we tell basically HTTPD with proxy pass directive. We tell it to do h2 in clear text to this, which in fact in my case is a Tomcat running there. I will skip the demo. I might try if I have time. So I want to get some questions. That's why I'll push the demo till the last minute. So are we H2 ready? Yes, because even if you use it without push, it's already quite impressive. You have tons of examples in the internet, like images that are rendered faster. A safer crypto than an unsafe crypto. Everyone knows that it's more expensive, but that's the price we have to pay. Additionally, as it's multiplexing HTTP 1.1 instead the H2, well, you don't need to change anything in your application, because basically your application is your normal web app. There's no reason to change anything. It's going to, the H2, the browser is going to send stuff. It's going to be a multiplex, going to be demultiplex, and at the end, in the Tomcat, you're going to have your normal web app without any change. So, if you want to use H2, go for it. Is H3 ready? Well, first, it's still a draft. I don't know you want to run a server using a draft protocol, except you really want to take the risk that the next change is going to break everything, which in fact seems to be the case. Another big problem is using UDP versus TCP. We all know it's this, this kind of feeling. Why do people in the cloud have blocked UDP? You start to think like, because they want to optimize the kernel as much as they can, and they discovered that probably the UDP stuff needs some work. I didn't check the code, but I know that it needs some. If you want to touch the kernel, it's a good opportunity. There's stuff to do there. Actually, the other thing is, like, if you really want to get all the benefits of H3, you need a fork of OpenSSL to be able to do the zero ERTT. Zero ERTT means that basically you're not protected on a replay. In the case you're using the H2 protocol, the H3 protocol, you're protected against the replay, because basically the protocol will take care that it does not happen twice. But if you imagine that you would using just if we would just be using UDP plus the TLS 1.3 connecting two applications together, definitively you can with the zero RTT you can replay a packet. You can get someone in the network which will replay the packet. So definitively, in this case, we have to make sure that we can't replay something here. One thing what is going to be interesting is like, well, you will also have no need to rewrite your server application there, because basically the things are going to be multiplexed and sent to you. So basically, what the end customer is going to get is a page which is going to be displayed a lot faster. So that's a gain. But I would say, like, for the moment, wait. If you want to experiment, feel free. But there's a kind of orange blinking stuff telling, like, for the moment, wait. And then I've been presenting H3 3 times, and I've been always telling wait, and the number of the draft protocol have changed every 2 months or something like that. And trust me, it does not work. All those servers implement only one, because I think I've not looked to the detail of the change, but it looked like it's either they don't care of making or putting all the ifs in their code, either it's not so easy to support more than one version of the protocol. So this is the space for question, and I will try to make a demo if I have extra time. I have 5 minutes, and one of my servers was not starting before, so it might be that I'm not able to do a demo. So if you want to know a little more, if you have any question, you can mail me. This is the URL of the HTTP2 stuff. If you want to look about H3, the curl developer, Daniel, have been doing a lot of things. So you just look for, he wrote a book on it, so you can look for HTTP 3 explain and curl, and then you have a wonderful book with all the explanation. Curl have a lot of wiki that explain how you can build the things. So if you want to experiment, there's a lot of things. And now I have space for question, and if there's no question, I will try to make a demo, and then you have to stop me because I'm the next speaker, and I
When I use a reverse proxy, can I then use HTTP2 without encryption? So plain text? Yes, this works.
Yes, yes.
So only from browser to the server.
Yes, the browser won't accept to do H2 in clear text, but it's quite interesting. It's always interesting to do the TLS termination in C, in HTTPD, or in TrafficServer, because if you use Java, doing number crunching I've been improving, but it's still a bit slow. In the past, it was extremely slow. Like I did test something like 5 years ago, and I was desperately looking. After doing the automatic measurement, I was desperately looking for I must have done something wrong. Java must be somewhere in the curve, and it was on the 0 line. Like doing nothing, and I was saying, oh shit, that must be a bug. Then look, you scale up, and then you say, oh yeah, it's doing something, but it was very. Now it's still slower, and it's definitively why there's also all sort of kind of improving things by compiling it, like the Graal Remy was showing before.
We can have one last question if anyone has.
Yeah, you have one question.
I got a couple. Hello. I got a couple of questions. One is regarding one moment in which you told us that it's not possible to do forwards. I mean, are you talking about the HTTP redirect that goes to the client, and after that it goes to another place?
The forward proxy is basically you are in a big company, and they don't give you direct access to internet, and they're making a forward proxy for you. Okay, so forward proxy is not possible in the case of H2 or no H3.
Okay, and the second question is regarding the next of the pieces in the ecosystem. I mean, what about the load balancing? Because nearly all of us have web servers, and with reverse proxy to application servers. Did you do some tests or just to see around if the load balancing companies are implementing the proxy or the protocol? Sorry,
I have not looked if the load balancing company were taking care of these things. What I can tell you is, like, basically at some point we have the things in HTTP 1.1 when it's demultiplexed, and then you can plug your load balancer there. I mean, you can use mode load balancer with H2 without problem. I don't have an example, but I remember trying
the question was regarding HTTP 2.
Yeah, you can do load balancing.
Thank you.
But not with hardware device, to my knowledge.
So we'll be wrapping up here, guys. Thank you very much. If you have any other questions, you can feel free to take them offline. Thank you. Good job. Good.